Hi, everyone. Can you hear me? I think yes. So, I'm glad to be here. I really hope you enjoyed this wonderful event, just like me. So, have some time restriction. Let's proceed to the presentation right now. Today, I'll talk about how Zabbix can help us understand what's going on the network, using some new Zabbix 20 functions applied to some network traffic data, in this case, net flow data, and then generate or improve some network visibility for network administrators by example, okay? So, let me introduce the issue. Most people I talk to about monitoring share the same question. How can I get some network visibility on my company? How can I monitor my network environment, my network infrastructure? I have no idea where I start. Please give some tips. So, after this short conversation, after some research, these professionals decide, I'm going to use Zabbix. In fact, you know, Zabbix is free, Zabbix is easy. We know we can download and install Zabbix in a few minutes, create some hosts, or let Zabbix discover them, or create with using LLG for hosted prototypes, and apply some out-of-the-box templates, and like magic, metrics will appear. In fact, it's too easy, but what's the first result? The first result is an operational layer monitoring, and it can be very, very useful. But these professionals, I think, network administrators, needs a bit more. They need a tactical layer monitoring, because they're looking for network behavior. Don't only bits and bytes. Bits and bytes can say too much for us about network behavior, but we need to know how to use it, okay? So after this briefing, our mission here is very, very clear now. We need to create some tactical layer monitoring and improve network visibility for all professionals, okay? In the end of this presentation, we will have both an operational layer monitoring and a tactical layer monitoring. I divide this presentation into a few topics to try to speak in a didactic way. So during this presentation, we have a small slices of pieces of information until the final assembly to the final puzzle. Let's start. Contextualizing, what do I really need to monitor on an IT infrastructure environment? Commonly, I've been looking for and monitoring some components of this operational layer of this infrastructure, like CPUs, memories, network interfaces, some resources like bytes consumptions, percentage consumptions, incoming and outgoing traffic. It's an okay monitoring, but it's not enough. So when I think about network traffic specifically, I need to talk about NetFlow. But remember, this presentation is not about NetFlow. It's about how Zabbix can help us understand network behavior using NetFlow applying some new trained functions to NetFlow data and understand network behavior. So in the future, it will bring to light some unknown behaviors on our network. Okay, let me introduce a simple scenario. Here you have a common component network, some users on computers, smartphones, tablets. These users need to consume internal services. Sometimes the services are on the internet. In this case, they need to go through a firewall or a router. And in the future, these devices, firewall and router, by example, will be the key to export NetFlow data to Zabbix. We can discuss this implementation maybe on the party, not now. But from this moment, Zabbix already can read, store, analyze, show some information in graphs. In fact, a very, very nice implementation. Let's talk about ordinary data. What does ordinary data means in this case. Remember, before this implementation, Zabbix knew something about incoming traffic, outgoing traffic, other metrics, ordinary data. But now, let's check a part of this implementation. So, this full print screen is a part of this implementation, this the beginning of the tactical layer monitoring. Here, I'm seeing some information about sources and destinations, packets, flows, and bytes sent or received to or by a specific device. A very nice implementation. Let's take a closer look. Bytes by source, packets by source, flows by source, and the same information about destination. A very nice implementation, but remember, ordinary data, because it's NetFlow with Zabbix. So, on the right, additional information, a 5-tuple concept that involves a row of values that involves source and destination IP, source and destination ports, and usage protocol in these communications, and additional information like flows, packets, and bytes. Okay, here we have some very, very interesting, very nice implementation, bytes consumption by service considering all network discovery services using LLD. Very, very quickly, in green frame, you have a specific service. You can manage other services here, like DNS consumption. So, total bytes received on the network on yesterday. In blue frame, received today so far. When I compare both, I have a percentage change. So, the beginning of the tactical layer monitoring tells me something about network behavior. Very nice implementation. Very quickly, here, in a purple frame, we have the first change function in action, retrieved average bytes received in the previous hour. Here, last minute, and here, a very nice implementation, a percentage consumption for this service considering all network services on the network. Very nice implementation, but again, ordinary data. So, what's new? We need to talk about extraordinary data. What does extraordinary data means? I think extraordinary data, in this case, is a simple concept that invites us to think about new metrics that can be generated using old data received by Zabbix in the past. By example, to calculate a baseline monitoring, standard deviation monitoring, and anomaly rate detection. Right? Let's see. Please don't worry about amount of frames, amount of colors, amount of pieces of information. Can be very, very confusing. So please, just focus on the first line and the first graph in this case, because the rest is the same information but aggregated by different protocols, but it's doing the same thing like first line here. I will explain details in next slides. Again, very, very quickly, bytes received all network, different the previous one. It's related to all bytes received. Doesn't matter what kind of service we're talking about. And bytes received yesterday, again, percentage change, and I compare both. Very, very simple. I calculated item, but a very, very nice implementation, the beginning of the tactical layer monitoring. And here, very, very quickly, we have 3 frames using change average functions to start. Bytes received in the previous hour, not last hour until now, previous hour, last full hour, because it's based on change cache. Here, standard deviation indicator, let me explain details in next slides here, and finally anomaly rate, and I will pass like a kind of X-ray to explain this in details right now. Before, let's talk about baseline, a briefing. I have a question. How can I predict what to receive? Using baseline monitoring. Remember, over time, Zabbix has receiving some values, and using a specific calculated item, baseline WMA, I can see what's next. A kind of prediction in Zabbix, a statistical implementation, very nice. And about standard deviation, remember, Zabbix has receiving some values, baseline is calculating what Zabbix is expecting to receive, but instead, Zabbix can receive some difference. So this difference can be represented in the future by standard deviation indicator. Okay? And finally, anomaly rate. What's anomaly rate? A simple way to understand anomaly rate is a way to detect some anomalies on the network based on the number of deviations found in a detection period. Just a briefing, I will explain details in next slides. So, let's talk about baseline, oh, too dangerous. Next, baseline monitoring now. What are you seeing here? The blue line is indicating what Zabbix is expecting to receive, while the purple bar is indicating what Zabbix is receiving in fact. Okay? Clearly, something is wrong. Zabbix is expecting to receive at about 40 megabytes, while it's receiving here at about 2 megabytes. What's wrong? I have no idea. But remember, before this implementation, I was completely blind. But now I have something to investigate. So, more questions than answers. But a very nice implementation here. I think it's a network administration dream. Expected bytes and received bytes are very, very similar. It's so crazy, I think, but for this use case, it's true. So, an X-ray. Look here. I'm using a relative time shift to browse in data timeline and calculate what Zabbix is expected to receive for the previous hour, considering 7 days like a seasonality. Here, because baseline monitoring is based on averages, remember, trend cache, so I'm talking about the previous last full hour and not last hour until now. So just to explain, I'm considering this time, but observing 7 days, the same hour over 7 days, just browsing a data timeline. Okay. And here, just to explain why using a trend average and not average function. It's very simple. It's not fair to create a baseline monitoring considering history values, not consolidated yet, like average bytes, but here I already have this information. So it's easy to compare both, what's expecting and what's received, but both values considering average. Okay. Standard deviation. You know this image. This is a common image that can be found on the internet. And remember, was the received value the expected value? So, if my received value is closer than expected value, standard deviation here is closer to 0. Otherwise, it's far from 0, like here. So this purple frame is indicating standard deviation for this use case monitoring. A simple item value widget, but you can create a graph to analyze standard deviation evolution or involution. Can be very, very important. Using the same logic, just use it in baseline WMA monitoring. It means for the previous hour, considering 7 days like a seasonality. Again, another X-ray, just to explain this retrieval value, considering this time, this hour, and other average bytes and semi-hour over 7 days. These values will be used to calculate standard deviation and result in this value. Very nice implementation, in fact. Here we have our puzzle. Let me think. Expecting to receive, indicating by blue line. Purple bar, what Zabbix is receiving in fact. Clearly, there's some difference. This difference can be represented by standard deviation monitoring. Makes sense. Again, a kind of prediction based on average, a statistical implementation needs some investigation and a correct implementation. Let me back. Look here, 0 bytes. Look here, 0 bytes. Is it true? I don't know. It's just a use case. But these values are reflected in this calculation. So, investigation. Okay? So, finally, anomaly rate. Remember, the simple way to understand anomaly rate is a way to detect some anomalies on the network based on the number of deviations found in a detection period. Okay. Here, I'm using trend_STL function based on trend function, observing 24 hours, looking for the number of deviations that reached 2 deviations. And a detection period is not here, is here. It means I'm looking for the number of deviations considering this entire period, last day, 20 hours ago, until now, using this algorithm. Okay. An X-ray, again, just to check some possible algorithms, and here, what I'm using. I will not explain. I think it's another talk, maybe, to explain in details how these algorithms works. So next time, I think. But here we have like something 30% of anomaly rate. It means considering this detection period and these parameters, 30% of the received values can be considered not normal. A question, am I in trouble? Maybe yes, maybe not, I don't know, because depends on your business rule. It's a simple use case. I can say you are trouble or not trouble. But look here, the last simple graph analyzing anomaly rate evolution or involution. Again, I don't know if 30% of the values represent some problem, but clearly something is happening every day at about 6 p.m. So what's happened? Again, before this implementation, I was completely blind, but now I have something to investigate. And I think network administrators will be very, very happy with this information, I think. Okay. Very, very quickly conclusion. In this use case, I just used a short time to observe something and calculate something. Just a use case, educational purpose only, okay? So you must translate your business rules to a trusted formula to calculate something here. Okay, again, building some graph to analyze standard deviation evolution. I think our goal was achieved. Zabbix can treat net flow data. We can create some tactical layer monitoring using baseline monitoring, standard deviation monitoring, and anomaly rate detection to improve or generate some network visibility. Okay. Challenge from this moment. I just didn't create some triggers to fire because just a use case. Again, you need to translate your business rule in a trusted formula, trusted triggers to reflect your real-life scenario on your company, by example. Please, if you don't use Zabbix.plus yet, make a plan and start, because Zabbix Change Functions, very, very nice implementation. Thank Zabbix for that. And okay, we need evolution. I think this is it. Remember, operational layer monitoring is the first result of some off-the-box templates that can be assigned to any host. But we can't stop here. We need to evolve. And if you don't find a feature that help you, just extend Zabbix, like this implementation here. Okay, again, more questions than answers, because this implementation bring to the light some unknown behaviors, from completely blind to something to investigate. I think this is it. Thanks so much. Continue to enjoy the summit.
Thank you.